everyone. Thank you for this great opportunity to have our presentation. My name is Takumi Nomura, Chief Engineer of Honda Motor, and I'm also a Vice Chair of JASPAR Next Generation High-Speed Network Working Group.
My name is Katsuyuki Akizuki. I belong to the Mobility Solution Development Department of NEC, and I am also member of JASPAR.
Today, we'd like to talk about our study of SOA platform for the future in-vehicle networks based on JASPAR's automotive use cases. Here are the co-authors. All of them are members of JASPAR and excellent engineers of Japanese automotive industries. First of all, let me introduce JASPAR. JASPAR is a Japanese non-profit organization of automotive industry. JASPAR has been established 2004 and led by 5 board companies such as Toyota, Nissan, Denso, Toyota Tsusho, and Honda. This is an organization chart of JASPAR. JASPAR has 10 active working groups. We are from Next Generation High-Speed Network Working Group. One of our important missions is contribution to create the international standard of automotive Ethernet. That's all for JASPAR. Here are the contents of this presentation. First, we will be discussing the background of this presentation. Then, we will discuss about the benchmarks of the candidates which we have selected. After that, we will talk about the conclusions of this study based on the benchmark results. Lastly, we will present the future works of JASPAR. Let me introduce the background of our study. To support the revolution of the automotive industry, such as case, much more software resources will be required than ever. SOA is attention-getting. Since software release and function addition, update can be achieved easily. While multiple candidates of SOA platform exist, we do not know what is a conqueror in the SOA platform. In other words, from the OEM's point of view, we want to clarify the most reasonable platform of SOA. As you know, some IP is the most favorite candidate. However, it is designed for local automotive networks. Can it adapt connected application? On the other hand, DDS and REST are the proven in the consumer market. However, they are not designed for the automotive network. For these reasons, we did the benchmark some IP and DDS by comparison to clarify better SOA platform for the future in-vehicle networks. Our study includes desk research and analysis of both protocols, clarification of the advantage and disadvantage in terms of QoS and security based on the given use cases. It should be noted that the use cases are referred from the next generation E&E architectures proposed by JASPAR. Via such activities, we will lead the conqueror of automotive SOA platform. I will now introduce the survey of the SOA protocols. The first one is SUM IP. As you know, it is the most favorite automotive SOA platform. Since it is designed for automotive use, it's lightweight. SUM IP can be implemented at low cost. Many devices will utilize SUM IP. It is also striking that it is defined as part of the BSW module in the AUTOSAR Classic platform and unified into communication management in the AUTOSAR Adaptive platform. These features are the advantage of SUM IP over the other SOA protocols. The second one is DDS. We JASPAR choose this as an alternative since DDS middleware is defined in adaptive platform. DDS is widely used in various fields such as aviation and railway control networks. Good knowledge can be benefited by other fields. DDS's advantage is support of QoS and security. It includes a framework to guarantee QoS and security. However, actual QoS guarantee requires QoS controls, such as IEEE 802.1 TSN. These features makes DDS a strong candidate for the future in-vehicle networks. Next, we considered the perspective of protocol stack. This figure shows the protocol stacks of both protocols. We have an impression that SUM IP is composed by the most basic components for automotive usage. On the other hand, DDS has a highly efficient abstraction layer. We think of this feature is developed to realize various fields applications. Next, we thought about AUTOSAR Release. This table shows some IP and DDS related AUTOSAR documents. Some IP is ahead of AUTOSAR, obviously. In comparison, DDS is catching up. Regarding security, DDS already includes a set of security functions. User authentication and digital signature are not necessary for automotive applications. Some IP does not include security functions. However, with other general technologies such as standard Ethernet and TCP/IP, AUTOSAR modules, some IP can be performed securely. Let me summarize what we wanted to mention in the first half. Some IP is defined from an automotive viewpoint, so it can be implemented at low cost, and it supports AUTOSAR. DDS has many achievements in industry automation and so on. Thus, good knowledge can be benefited by other fields. It also includes a framework to guarantee QoS and security.
These traffic types has been discussed by the IEEE 802.1DZ, and JASPAR applies specific use cases and L2 to L4 requirements. JASPAR thinks DDS is a good choice for some traffic types where low latency is required for evaluation at this time. The reason is that QoS is clearly defined compared to some IP. So low latency of L2 can be easily realized. Some IP may be equivalent if supplemented with other protocols. Even in its defense in depth, some IP needs to complement it by other common technologies. In other words, we can provide a solution as long as we complement it. DDS has been originally applied in consumer industry, so it is assumed to be connected to external networks such as outside the vehicle, and the necessary technology is defined from the beginning. JASPAR considers which is a better candidate of the SOA conqueror. It shows the advantages and requirements of some IP and DDS. Some IP supports AUTOSAR and has been defined from a current automotive viewpoint, and some IP can be implemented at low cost. On the other hand, Some IP requires QoS and security guarantee. To support QoS or security, some IP must be combined with the other frameworks. By combining some IP with the other frameworks, the cost of in-vehicle design will increase. DDS includes a framework to guarantee QoS and security. However, actual QoS guarantee requires QoS control such as IEEE 821 TSN and can benefit to other applicable fields. DDS requires automotive support, AUTOSAR, API, and so on. According to JASPAR's use case, DDS is a strong candidate of SOA platform from a viewpoint on QoS requirements. According to the JASPAR's benchmark from a viewpoint of security requirements, DDS is suitable for connected because of easiness of implementation, but some IP is adequate for in-vehicle communications because of the achievements. Some IP requires QoS and security. DDS requires automotive support. Here are two future works from JASPAR. First, DDS provides the framework of QoS, but does not show how to implement it. Some IP does not even have a framework to support QoS. To meet QoS policy required by DDS, we need to cooperate with lower layers defined in IEEE 802.1 and implement each protocol appropriately. This is a common issue for SOA protocols, not just for DDS. To complement the advantage of SOA protocols, we study how to apply TSN automotive profiles of IEEE 802.1DG. For example, use the shaper defined by QAV, QVV to meet the QoS policy. Second, the introduction of SOA platform makes in-vehicle services frequent update with ease, including additions and deletions. With the service update, it is necessary to flexibly change the related network setting, QoS, bandwidth, routing, and so on. In vehicle SDN, software-defined networking that enables dynamic network changes is expected. We study requirement, architecture, and realization method for in-vehicle SDN. For example, feasibility study of applying TSN. Which TSN protocol can be subject to SDN configuration changes. Thank you for your kind listening.